In this video, we want to find the critical numbers for this given function here. And just to review, here's your definition. If a number c is in the domain of a function f, then c is a critical number, or is called a critical number of f, provided the derivative at c is equal to 0 or does not exist. So note, c has to be in the domain of the function. So all we really need to do to start off is compute the derivative of this function. And first note that for the function x minus 1 in the denominator means that x equal to 1 gives me a 0 there. That's undefined. So x equal to 1 cannot be in the domain of the function. Therefore, x equal to 1 cannot be a critical number. So let's start by taking the derivative, and we're going to use the quotient rule since we have a rational function here. So the derivative then is given by, in the denominator, all we do is square what we have there, x minus 1. So x minus 1 will be squared. And then it's the denominator, x minus 1, times the derivative of the numerator, x squared plus 2, x squared plus 3. So that's a 2x there. And then it's minus the numerator times the derivative of the denominator, which is x minus 1. Derivative of that is 1. We simplify this. So multiply through here by 2x, we get a 2x squared for this right here. And then 2x times minus 1 is a minus 2x. And then it's a minus. Distribute here the negative here, be minus x squared minus 3. And then we combine. So 2x squared minus x squared gives me an x squared. And then I get a minus 2x minus 3. And the denominator I have x minus 1. Quantity squared. So we want to look at the values of x for which the derivative is 0. So we simply have to set this numerator equal to 0. We take x squared minus 2x minus 3 and set it equal to 0. So then we solve this equation by factoring x minus 3, one factor. We get x minus 3 and x plus 1 is equal to 0. Set each factor equal to 0 now. X can be 3 and x can be negative 1. So x can be 3 or x can be negative 1. Those are the values that make the derivative 0. So the critical numbers are x equal to 3, x equal to negative 1. Notice potential critical numbers are numbers where the derivative is undefined. So in this particular case here, because the denominator is 0 at 1, x equal to 1 could possibly be a critical number, but the condition is that the critical number has to be in the domain of the function. And as I pointed out, x equal 1 is not in the domain of the function because the function is not defined at x equal 1. So the only critical numbers we could list here are x equal to 3 and x equal to negative 1. And of course you can use critical numbers to sketch the graph of a function. You can use critical numbers to determine, along with the calculus, whether a function is increasing or decreasing. You can use them to find relative extrema, that it would be a maximum or a minimum. But right now we're just finding the critical numbers. And again, those are 3 and negative 1. Thanks for watching. We'll see you next time.